Hello, my name is Roy Simpson, and I'm a professor of mathematics at Cosumnes River College in Sacramento, California. This is another proof in my long-standing series, Proofs in Differential Calculus, and this is a proof that the derivative of the tangent is equal to the secant squared. And if I want to be rigorous about it, I should say the derivative of tangent of x is equal to the secant squared of x. The way I'm going to do this proof is going to be with the assumption that you have already seen the derivative of sine, and you know that is cosine. So let me go ahead and put that under our prerequisite knowledge base here. So I'll hop over here. Let's see. So the prerequisite knowledge that you need to know that derivative of sine is cosine, just like I said. You'll have to also be very familiar with trigonometry. Specifically, I'm going to use some little used facts. Well, actually, these are often used in mathematics, but a lot of students forget these. Cofunctions. What do I mean by a cofunction? Well, I mean like sine and cosine are cofunctions. So it turns out that sine of an angle is the same thing as cosine of its complement. Okay, so that's what a cofunction is. Sine and cosine are cofunctions. By the way, it is also true that the cosine of an angle is the sine of the complement. Again, because they're cofunctions. And so you could say the same thing about the secant and the cosecant and the tangent and the cotangent. So we're going to use this, and again, like I said, all I assume here is that you've seen and know the derivative of the sine is equal to the cosine. It will actually be kind of fun to do it this way, because normally I would probably have already proven in class or used or told my students in class that the derivative of the cosine was a negative sign, but I'm not going to assume that you've seen that here. We're going to do this without that, and in the process of proving this, we are actually going to prove that the derivative of the cosine is the negative sign. So it's going to be kind of interesting. So here we go with the proof. I'll do it on this page because it's that short. We'll start with the derivative with respect to x of the tangent of x. And that can be rewritten as the derivative with respect to x. And of course, you know that the tangent of x is the same thing as the sine of x over the cosine of x. So we'll go ahead and do that. And you also know that the derivative of a quotient can be rewritten as a derivative of the top times the bottom minus the derivative of the bottom times the top, all over the bottom squared. So maybe I should have put that in my prerequisite knowledge, that you should already know the quotient rule too. I didn't think about that until I started kind of filming this, but you should know the quotient rule as well. So let's go back here, and I'll go ahead and write in the derivative of the sine times the cosine minus the sine times the derivative of the cosine, all over the cosine squared. So we now have that in there. And we already know that the derivative of the sine is the cosine itself. So I'll just go ahead and write this as cosine times the cosine. And of course we know that's going to be cosine squared, but I'm just taking my time with this, minus the sine. And as an aside, we're going to talk about what the derivative of the cosine is going to be. So let's go ahead and I'll change pen colors so you know that I'm doing this as an aside. I'll write this maybe on a new page actually. So we don't really know at this point what the derivative with respect to x of the cosine is. We're only assuming that we know what the derivative with respect to x of the sine is. However, I know that the cosine can be rewritten in terms of the sine. It can be written as sine of 90 degrees minus x, right? It's the sign of the complement. So let's go ahead and take that derivative. This was going to use the chain rule, which we already know as well. Man, I should have put that in as a prerequisite too. All right, well, that's okay. The derivative of the sine is the cosine of that 90 degrees minus x. And then using the chain rule, we hop inside that function and we take the derivative of negative x. So that'll be a negative 1. Now, if you do not happen to know the chain rule at this point in your academic career, that's okay. It's actually coming up usually next in a course, but this is a chain rule. We're just taking advantage of that. It's a very neat little rule you can use. And so I'm going to write the negative out front. It's the negative cosine of 90 degrees minus x. And of course, cosine of this angle is equal to the sine of the complement. And of course, the complement of this angle is actually just x itself. So this is negative times the sine of x. So if you happen to know about the chain rule, which I'm using, you could totally do this proof. Otherwise, you'll just have to rely upon maybe your knowledge that the derivative of the cosine is the negative sine. So I kind of cheated there, assuming that you may have known the chain rule. So I'm going to put in here the chain rule. If you don't know the chain rule, then like I said, you should probably already know that derivative with respect to x of the cosine is actually equal to the negative sine. So it is a bit of a cheat that I just did, making that assumption. Sorry about that. So let's go back here. Now that I know that the derivative of the cosine is a negative sine, I'll go ahead and put the negative right here. Put sine. And that's all over the cosine squared. Well, this is part of trigonometry here. Cosine squared plus sine squared, that's what the numerator will be. That's going to turn into a nice pretty little 1. And of course, 1 over cosine squared is the same thing as secant squared. That's it. That's all there was to this proof. Of course, like I said, I cheated a little bit because I kind of said that you already knew what the derivative of the cosine was, or that you already knew the chain rule. Not that bad. Usually by the time you get to the derivative of the tangent, you already know what the derivative of the sine and the cosine are. So that's pretty fair game. So I'll call it quits on this one. QED.